Welcome to Quantum Numbers Made Easy. We've been discussing the modern atomic theory, which can also be called the quantum mechanics theory, or the orbital theory, or the electron cloud theory. As with many concepts in chemistry and science, the quantum mechanics model of the atom is considered to be very complicated and confusing. But keeping in line with the KISS method, I like to keep it simple and keep it in step. Let's take a look at this complicated atomic model and make it simple by using the analogy of an Electron Hotel with 7 stories, or 7 floors. The 7 floors of the Electron Hotel correspond to the 7 rows on the periodic table. These rows represent the first quantum number, which are the energy levels of the atom. Every electron in any atom can be designated or represented by 4 distinct quantum numbers. Every electron in an atom is assigned a quantum number described by the Schrödinger equation, a mathematical expression. Quantum numbers indicate the different energy states of electrons in an atom. Every electron can be described by 4 quantum numbers, and no 2 electrons have the same 4 numbers. Quantum number 1 is called the principal quantum number. It's designated by the letter N, and it corresponds to the size of the electron cloud in the atom. And it also corresponds to the energy levels in the Bohr model of the atom, which are the 7 rows on the periodic table. There are 7 floors in the Electron Hotel, each representing energy levels. N equals 1, N equals 2, 3, 4, 5, 6, 7, corresponding to the rows on the periodic table. Each floor of the hotel has rooms, and the rooms represent the second quantum number, which is the sublevel of the energy level. The sublevel, or the rooms, correspond to the shape of the sublevel. The rooms are the S room, which is spherical. The P, standing for principal, are dumbbell-shaped. The D, standing for diffuse, are very complicated. And the F, standing for fundamental, are the most complicated. The number of rooms in the hotel, or the electron sublevels, directly corresponds to the floor number, which is the principal quantum number, N, the energy levels. The first floor has 1 room, which is designated the S room. The second floor has 2 rooms, the S and the P rooms. The third floor has 3 rooms, S room, P room, and D rooms. Fourth floor has 4 rooms, the S, the P, the D, and the F. And from then on, all the floors have the same, the S room, the P room, the D room, and the F room.
It's important to note that the modern atomic theory is mainly about 2 things: electrons, where they exist, and energy. If you follow this chart, you'll notice it goes 1s, 2s, 2p, 3s, 3p, and all of a sudden 4s pops in there before 3d. It's all about energetics. The 4s sublevel has a lower ranking energy than the 3d, so it goes first. Once you reach the 3p sublevel, 4s actually has lower energetics than 3d, so it comes first in the order of the quantum numbers. 4p, then 5s, 4d, then 5p, 6s, 5d, 4f, and so on. The third quantum number represents the orbital, which is the arrangement of the orbital in space, which corresponds to the couches in the rooms. When you have a hotel, you have rooms, and every room has furniture. So we're going to designate the furniture to be couches. The S rooms have 1 couch. The P rooms have 3 couches. The D rooms have 5 couches. And the F rooms have 7 couches. The third quantum number, or the couches, corresponds to the orbital orientation, but more importantly, it represents the region of high probability for finding the electrons. That's what the modern atomic theory is all about, that region of high probability. The fourth quantum number is the spin, and that's the people that sit on the couch. And you can have up to 2 people on any couch. And remember, the people are actually representing electrons. Electrons are negatively charged, and when they're together, they're going to repel each other. So that's why the spin is always opposite when you're dealing with electrons being in the orbitals or on the couch.
I've given you quantum numbers made easy in theory. Now it's time to apply the theory and make it practical. It's like riding a bike. You can read a book, somebody can tell you what to do. You need to get on the bike and ride. So let's start right at the beginning here with the element hydrogen. We're going to first write a nuclear symbol, and then we're going to do the 4 quantum numbers for hydrogen. Hydrogen's elemental symbol is an H, and we noticed on the periodic table that the atomic number was 1. That goes as a subscript on the left side. And the atomic mass was also 1. That goes as a superscript on the left side. Unless you're word processing, then you're allowed to put it on the right side. So looking at this, atomic number means there's 1 proton. And since it's a neutral atom, that also means there's 1 electron. So we only have 1 electron to deal with. The 1 electron enters our Electron Hotel and goes to the first floor. Quantum number 1, energy level, first floor. First floor only has 1 room, and that room is called an S room. Every S room has 1 couch, and you can have up to 2 people, but we only have 1 electron, so 1 person. There are the 4 quantum numbers, right? You have the energy level, the sublevel, the orbital, and the spin. The element helium, a noble gas, is on the right side of the periodic table. Atomic number of 2, atomic mass of 4. So we write the elemental symbol, He, with the subscript 2 for atomic number. Atomic mass is 4, superscript. 2 protons means 2 electrons. We enter the Electron Hotel, floor number 1, which has 1 room, S room. The S room has 1 couch. And there are 2 electrons, 2 people. Notice the opposite spin because electrons repel each other. And there are your 4 quantum numbers again. The energy level, sublevel, the orbitals, and the spin. Let's consider lithium. Here's lithium. It's in the first group. Lithium has an atomic number of 3, an atomic mass of 7, because you round up. We write the elemental symbol, Li, subscript 3 for the atomic number, superscript 7 for the atomic mass. Atomic number is protons, which equals the electrons when it's neutral, so there's 3 electrons. So we enter the Electron Hotel. Floor number 1 has 1 room. They're the S rooms. S rooms have 1 couch, which can take 2 people, or 2 electrons in this case. That leaves us with 1 electron. The first floor is full, so we need to go to the second floor. The second floor has 2 rooms, S and P. The S rooms have 1 couch. The P rooms have 3. There's only 1 electron, so we always go to the lowest ranking sublevel, which is S. SPDF. S is the lowest ranking sublevel. So that 1 electron goes there. We don't need the P orbital. Beryllium is element 4 in group 2A. Atomic number of 4. Atomic mass of 9 if you round up. So the elemental symbol is Be. Atomic number is a subscript of 4. Atomic mass, superscript of 9. Atomic number means 4 protons. It's a neutral atom, so the protons, positive charge, must equal the electrons, the negative charge. So we have 4 electrons to work with. So we enter the Electron Hotel. First floor has 1 room, that's an S room. S rooms have 1 couch, which can contain 2 people, opposite spin. First floor is full, so we go to the second floor. Second floor can have 2 rooms, 2S and 2P. S rooms have 1 couch, P rooms have 3 couches. There are 2 electrons left. We go to the lowest ranking energy member. That's the S sublevel. And there are the 4 electrons. 1, 2, 3, and 4. And you'll notice we don't need the 2P room. Boron is element 5, atomic number of 5, atomic mass rounded up to 11. The elemental symbol is B, subscript 5 for the atomic number, superscript 11 for the atomic mass. 5 protons means 5 electrons. Enter the Electron Hotel, first floor, 1 room, which is the S room. S rooms have 1 couch. Can take 2 electrons opposite spin. First floor is full. Second floor has 2 rooms, S and P. S rooms have 1 couch. P rooms have 3 couches. I have 3 electrons left. So we go to the lowest energy member, which is the S sublevel. SPDF goes in that order energetically on the same energy level. 2 electrons go here. So we have 1, 2, 3, and 4. That means we have 1 electron left over. That goes into the P sublevel. It could be any one of the 3 couches on the P sublevel. Carbon, element 6, atomic number of 6. Atomic mass is 12. Elemental symbol is C. Atomic mass is 6. Atomic number is 6. Atomic mass is 12. Atomic number 6 meaning protons. Neutral atom has the same number of protons and electrons to keep the charge neutral. So 6 electrons enter the Electron Hotel. First floor has 1 room, the S room. S rooms have 1 couch, 2 electrons. First floor is filled, so we go to the second floor. Second floor has 2 rooms, S and P. S rooms have 1 couch. P rooms have 3. We have 6 electrons to work with. We've already used 2. There's 3 and 4. We still have 2 left over. So we go to P. Now watch this. This is important. This is called Hund's rule. You can't have two electrons on the same couch in the same room. So they have to be separated because electrons have the same charge. They repel each other. So when you're in the same room, they separate as far apart as they can be. If you put that in science terms, when you're on the same sublevel, in the same energy level, electrons will get as far away from each other as possible before you fill in that same orbital. And we'll do one last one here. Fluorine, element 9, atomic number of 9, atomic mass rounds to 19. The nuclear symbol would be an F with a 9, meaning we have 9 protons. Therefore, we have 9 electrons to give us a neutral charge. We have 9 electrons entering the Electron Hotel. First floor, 1 room. The S room has 1 couch, 2 electrons. First floor is filled, so we go to the second floor. Second floor has 2 rooms, S and P. S rooms have 1 couch, P room has 3. I have 7 electrons left. Energetically, it goes to the S first. 3 and 4 go there. That leaves us with 5. Now watch Hund's rule again. That's the 5th one. That's the 6th one. 6th electron. 7th electron. Notice they have to be separated when they're in the same room or same sublevel. Then you add the next electron. There's number 8 and there's number 9. And that's the 4 quantum numbers. Made simple.